Ellipses. Yay, ellipses. Excellent. All right, so we spent Monday talking about circles. You guys weren't here yesterday. You were off seeing some colleges. And so we're going to continue talking about conic sections with ellipses. So just take a look and you see how they look a little different. How do they look different from circles? They're ovals, right? So imagine that if we had a circle, they take what they call, these right here, these blue points are called the foci. All right, it's focus points, but we say plural foci, F-O-C-I. And they pull the foci apart to turn it into an oval. Okay, so because of that, we have a lot more stuff. All right, we have vertices. All right, we have co-vertices, foci, major, minor axes, a lot of different stuff that you just read about. All right, and I'm going to show you how to find all that stuff in what we call the characteristics of ellipses. The whole point of this, of today and Monday, is we want to be able to graph ellipses and we want to be able to write the equation for an ellipse. Okay, so those two goals, just like with circles, right? Write the equation and graph them. All right, so these are the equations that we're going to use. All right, so take a look. How do these look different from Monday?
There's too many variables.
We have fractions, right? See how we have fractions here? But what else do you know is the same? The squared part? X minus h, y minus k, all that's the same. What about the addition sign in between? That's the same. All right, is it equal to the radius squared? No, we don't have a radius. All right, so it's always going to be equal to 1. All right, now, I just want to tell you right now that I'm not going to follow this necessarily. All right, do you see how for the vertical ellipse it starts with y? I'm always going to start with x. All right, that's my preference. If you don't want to, that's fine. You can start with y. All right, but the main thing is when you decide what type of ellipse it is, horizontal or vertical, that tells you which letter is going to get your A. And A is always the bigger number. Go ahead and write that down somewhere on your paper. A is always the bigger number. A is always the bigger number. All right, so what I want to do now is I want to start with a few examples that keep it straightforward, where the center is going to be at the origin, 0, 0. All right, then I'll let you guys try some, and then we'll get into that packet. I have another packet for you guys. Yeah, you love packets? All right, and that's where our centers are not going to be at 0, 0. All right, so let's look at this example. The first thing I always recommend to students is to sketch it. All right, so I'm just going to draw a little x and y axis. It says the center is 0, 0. All right, so there's my center. Where is a vertex point? 0, 8. So I'm going to say this is 0, 8. So if there's a vertex up there, there's also a vertex at 0, negative 8. Very good. All right, what about my co-vertex? 3, 0. So there's another co-vertex at? Very good. And you should be able to then see that this is going to be what type of ellipse? Is it horizontal or vertical? Vertical. Very good. All right, so just go ahead and make your sketch. All right, it doesn't have to be beautiful. Just we want to know this is vertical. Now, we're not going to need it right now, but I'm going to show you how to find all of these letters, A and B. And then when we get to the packet, you're going to see how you're going to need to use C as well. All right, the distance from the center to either vertex is A. The distance from the center to either vertex is A. So what is A? A is 8. All right, I'll repeat that again. The distance from the center to either vertex is A. All right, and then what do you think B is? The center to a co-vertex. So in this case, That's B. And B is going to be 3. Now, a couple of things they're going to ask you in the packet that we can talk about right now. The axis that connects your vertices. All right, so if you imagine there's a line connecting your vertices, which in this case is on the y-axis, that is called the major axis. And what is the distance of the major axis? It's 16. So anytime you see the major axis and they ask for the distance, it's always 2 times A. Always 2 times A. All right? Same thing for the minor axis. The minor axis connects your co-vertices, and that's always 2 times B, letter B, which is 6. All right? So again, all these things they're going to be asking about on the packet. Now, all this is well and good, but it doesn't answer our question. What is our question? Write the equation. All right? Now, what is the center? 0, 0. So what's H and K? 0 and 0. All right, so am I going to write x minus 0 squared and y minus 0 squared? No. You can, and that's fine. I will count it correctly. But I'm always going to write x squared and y squared. Now, we know they're fractions. And we know it's equal to 1. Now, here's the question. In the formulas, it says a squared and b squared in the denominator. Notice I started with the letter x. I'm always going to start with the letter x. But here's the reason that I made you do the sketch. This is what type of ellipse? Vertical. All right? And when you think vertical, what axis should you think about? The y. So the y value here, that denominator is going to be the largest. All right? It's going to get a. And it's not just a. If you look at the formula, it says a squared. So it's going to be 64. Now, if you wrote y squared over 64 first, that's fine. I don't care. Right? That's what the formula tells you to do. But I'm just letting you know I will never do that. I'm always going to start with x squared. So the decision you have to make is which gets the biggest number. Yes? The reason why I do that is because when you get the final and when you get to questions on the ACT, SAT, they do it this way. All right? So I'm trying to help you prepare to how can you figure it out without thinking which one has to come first. Because again, this is addition, right? So does it matter the order in which I add? No. So it's okay. If you want to put y first, that's fine. All right, so what's going to be the denominator for x squared? It's going to be b squared, which is 9. Are there any questions about this? Yes, Shante.
Why did you put x squared instead of x minus h?
So h and k is 0 and 0, right? Because that's my center. So if you wanted to write x minus 0 squared, that's fine. But anytime you add or subtract 0, you don't actually have to write it. Good question. Any other questions? Question? Okay, great. Let's try example 2. Right? It's so straightforward. You guys are going to love it. Just forewarning, when we get the packet, it's going to get a little more challenging. All right. Let's draw this one. My beautiful sketch. Again, I'm keeping it straightforward to begin so you can just get the feel for this. Where is the center? 0, 0. This time, though, where is a vertex point? So notice that's going to be on the x-axis. So I have 9, 0 and negative 9, 0. What about my co-vertices? 0, 5 and 0, negative 5. All right, and I can make my beautiful ellipse. It's just a sketch. The whole point of doing the sketch is to determine what? What kind is it? Is it horizontal or vertical? This one is horizontal. The major axis, the longer axis, is on the x-axis. So it is horizontal. All right, so let's talk about finding A and B. This time, where am I going to draw my A? On the x-axis. So from the center to a vertex. So what is A going to be? Very good. From the center to a co-vertex is B, which is 5. Yes, more people. Thank you. Now, they're not asking for it, but what is the length of the major axis? Very good. And the minor axis? 10. So you just double A and double B. Yes?
Are you going to ask that on the
I don't know, maybe. I don't know. But I will ask it on the packet. Yes?
Will there ever be a question where like the vertex is like 9, 5 or 9?
Oh, yeah, absolutely. Yes, you're wondering, are we ever going to get a center that's not 0, 0? And maybe it's like, this is 2, 4, so then it would be like 2, 10. Yeah, oh yeah, for sure. That's where I think sketches come in handy. Always sketching it. For the length of the axes, yes, you just double that, multiply by 2. Indolesia, yes.
Wait, how did you know it was horizontal?
How do we know it's horizontal?
Because
The longest axis will tell you that, and the longer axis is this way, which is horizontal. All right, now, as I said, we're keeping it straightforward, so it actually is on the x-axis. It won't be when you get that packet. All right? I know, like you guys keep thinking, I want the packet! Right, Guillermo? Exactly. All right, so let's write the equation. I'm always going to start with what letter? I'm always going to start with x. All right, the center is 0, 0 again, so I'm just going to have x squared over something plus y squared over something equals 1. So this time, though, it's a horizontal ellipse. So that means which one's going to get the largest denominator? The x. So that's going to be a squared, which is 81, and b squared goes under y, which is 25. Excellent. Very good. Any questions about this one? For those of you that just walked in, you probably have lots of questions. That's okay. You'll have plenty of time to figure it out. All right. Yeah, Josie. Yes, so that's why you decide which type it is. If you tell me it's horizontal, the larger number goes under x. If you tell me it's vertical, the larger number goes over y. Because think horizontal x direction, vertical y direction. All right, go ahead and try these at your boards.